we actually need cloud services, what do we really mean by that? And how can we actually identify them? Find out more next.
You're watching IT Pro TV.
Welcome to the IT Pro TV A Plus show. We are now actually taking a look at the idea of cloud services as well. And of course, Mr. Wes Bryan is going to help us to clarify that and help us to understand what we're actually talking about. Wes, what are we going to be taking a look at here?
Sure, Ronnie. So in this episode, what we're going to be looking at is demystifying some of the concepts surrounding the cloud. We're going to look at cloud deployment models and what that really means for us, as well as some of the service models that they have out there that we need to be able to identify, as well as discussing some of the characteristics surrounding the cloud. That's what we'll be looking at, Ronnie, here in this episode today.
All right, sounds like a lot. Let's go ahead and head on over to the bench.
All right, everyone, come on over here and follow me. We are logged in to a cloud-based platform already. And before we actually dive into looking at any of that or discussing that, let's go ahead and let's start out with what the heck is the cloud? Well, what is the cloud? When we look at the cloud is I want you to think of it as a way that you're going to use somebody else's network. Somebody else has the resources, all the hardware, the cabling, if you will, the security, the climate control systems in their data center. They've got a network and they've got a variety of services, and they are willing to let you use them provided you pay a monthly fee. That it largely is what the cloud is. Believe it or not, when you were using internet service providers in the earlier days, you might consider that using their networks the earliest portions of the cloud. Now, we didn't have unrestricted access for sure to those networks, but today it's gone a lot farther than that. And with that, we have to talk about some of the cloud deployment models, or more specifically, sometimes generically called just the cloud models. Ronnie, you know, when I think of cloud, one of the things I think of is, like, for instance, Azure. I think of Google Compute Platform, GCP. Maybe you've heard of a little company called AWS, right? These are all cloud providers, all right? And, for instance, I'm logged into Azure here, all right? When we look at Azure and AWS and the Google's Cloud Compute, or GCP, these are all forms or what are known as public cloud. All right, and what is the public cloud? Well, the public cloud means that you have a service provider that gives public access to a variety of customers to their internal infrastructure. That's why they say public cloud. It's available to the public. That's a little bit different than one of the ones that we have to talk about, which is called the private cloud. All right. And Ronnie, I know I did them a little bit out of order, but the public cloud is probably one of the ones that you're most familiar with, right? We recognize names like AWS. Well, I, as a customer, can pay the AWS, if you will, and by association Amazon. I can pay Microsoft on their Azure platform, and then I could use their services. I can do a variety of things, for instance, like creating virtual machines. I can use software. I can use app services, create storage accounts, and I can do this myself. Ronnie could do the same thing. In fact, Ronnie has done the same thing. We've both got tenants in the Azure space. The great thing about the public cloud is, though, Ronnie's assets that he controls within his cloud is called a tenant. He has one tenant. What you see right here is what's known as my tenant. Public clouds are multi-tenant in the fact that they provide multiple customers with access to the resources from a provider, but we don't have access to variety other customers' infrastructure. It's one of the benefits of the cloud. Now, the private cloud I mentioned is a little bit different. A private cloud is when you have a corporation that gets all the benefits of a public cloud, but they have it on-prem, or maybe not on-prem, maybe it's scattered across multiple locations, but it's only available to that corporation. That's a very expensive lift. And there are some times when certain companies might want to do that. Now, the cloud has come a long way when it comes to data privacy standards and security standards, but they might have a business model that says, hey, we cannot put data on somebody else's server. We need to know where the data is. We need to control the data center. So what we're going to do is we're going to spend the money to build our own cloud infrastructure. All the same technologies that you see that I have access to with this web interface in the public cloud, but now it's owned internally by a single company, right? Very expensive endeavor, but there are times when companies need to do that, typically due to some kind of legalities or some compliance regulation that they need to follow.
Yeah, when it comes down to it, I think that a lot of times the way that I think about it relatively easily is that with public cloud, we are going to be using somebody else's equipment. But here's the neat thing, Wes, that even though your tenant is separated from mine, we actually may still be on the same physical machines that are actually out there. So Wes doesn't actually own the machine. I don't own the machine. Azure actually owns the machine, but they can separate that out so that I can't get access to Wes's resources and he can't get access to mine.
Sure.
And in the private cloud, I literally can't actually get access to anybody else's because it is actually the equipment that I am actually paying for the usage. So if that's actually a private cloud that I built, I own the entire infrastructure itself. But if I'm actually just renting it, I can actually probably go to AWS and create a private cloud, but that means those resources are dedicated to me, and I'm going to pay a premium for that.
Yeah, most definitely, Ronnie. And I'd like to build upon that conversation. So let's talk about responsibility, right? You talked about, hey, that I own those resources, right? When we talk about private cloud, one of the benefits of the public cloud is I don't have to maintain that hardware. I don't have to maintain the network connections, right? I'm paying somebody else to do that. All of that is abstract or hidden from me. In a private cloud, you own those assets. You also have to maintain and support them. So again, it's an added lift. It's a little bit more expensive. Now, Ronnie, probably one of the most, and join in on the conversation here, is the fact that probably one of the most common models that we see today is what is known as the hybrid cloud model. Right? We talk about the hybrid cloud model. What are we talking about? Well, with a hybrid cloud model, we're talking about a blending of public and private, right? We have a certain amount of resources that are on premises, on our location, and then we move some of the assets that we want up to the public cloud, and we connect the two. That's a hybrid cloud because it's combining aspects of the public cloud that we maybe offload some of those resources to and let them manage it, but then we also have some certain amount of resources that are within our location that we have to manage and maintain. And Ronnie, if I understand it right, this is really one of the most popular cloud deployment models that we have in the industry today.
It really is because of the way that businesses tend to run. If they actually are running with any type of compliance issues that they need, especially handling people's information, they may store that on their own private cloud, but there are services out there that they do need access to, but they don't actually need complete and dedicated access. They just need to provide it as a service. Well, they might head into the public cloud arena to be able to actually use some of that. And so that actually allows them that opportunity to actually combine the idea of the private cloud with the public cloud, turn out to be what we tend to call the idea of the hybrid cloud as well. The mix of these actually seem to actually give us the best bang for the buck, and that's why we tend to see it more often.
And sure, probably one of the last ones is a little bit more confusing is the community cloud, all right? And I want you to just think about a community, right? When a community comes together, you got more than one group, more than one person, and they're all kind of working together collectively for whatever the end goal is. We have to understand that you have organizations that have that too, right? So for instance, you got a doctor's office that works with, medical records. You got a doctor's office that also works with insurance companies, right? Well, they have a common goal. They're giving health care to patients. And sometimes they need access to the same resources. Well, you can have what's known as a community cloud, where you have a cloud environment that is being utilized by more than one group. Another common aspect of this is when you have an organization, right? Let's say, for instance, if we decided to deploy it here at ACI Learning, right, we've got a development team. And our development team is constantly working, and they've got what's called a non-prod, a non-production environment, right? Well, we could create a cloud within a cloud that is just for the development team that doesn't affect the assets, if you will, of our production environment. But then as they test, they can push stuff up to the production environment, where the production environment is a separate cloud within a cloud as well. So these are the community clouds. Think of it as a cloud within a cloud. And it's one of the ones that's a little bit more harder to wrap your mind around. The main point about this deployment type is that you have two organizations or multiple groups of organizations within one that have a need for access to the same resources, hence the community cloud.
All right, Wes, well, that's not the only thing we need to talk about, right? We need to actually think about the idea here of, service models as well, because I'm going to get that confused with deployment models.
That's right, because deployment models are essential. Think about it as like, how do I access the resources and where are those resources located, right? That's the deployment models. What the cloud deployment offers are the services, right? What are the services that we need to be aware of? Well, there's three of them that are the most common ones, and those are the ones that are most widely agreed on, and that is something known as software as a service, that's something known as infrastructure as a service, and platform as a service. Let's go ahead and let's talk about software as a service, because whether you know the term or not, you're probably familiar with it and you just didn't realize that maybe it was called that. And what I mean by that, software as a service is where the cloud provider provides you an application, software as a service, and they maintain the entire application, updates, all of that. The only thing you need to worry about is maintaining your data, right? So what am I talking about? Well, if you're not aware of what software as a service is, maybe you have heard of a little company called Google that offers Google Docs, right? The G Suite is what it used to be called. I don't know if it's still called that. Workspace, I think it's called Google Workspace today. If you've ever used Office 365 or Microsoft 365 as it's called today, but it's more than just the Office suite, and maybe you've used one Word or PowerPoint and you've done it through a web browser. That's software as a service. If you've ever heard of a little huge company called Salesforce, right? Salesforce is one of the largest software as SaaS, as they call it, software as a service company out there. Let me give you an example. I'm here in Azure, and Azure also has a software as a service too. And let me kind of just zoom in here. They have their SaaS platform, and what this is it's a collection of third-party providers that have these various software as a service offerings, and all you end up having to do is just connect to them, and you can create your own. I'm going to cancel the certificates. That's not something we need to talk about now, but here are all of the variety of things that third parties offer as software as a service, right? So software as a service is the ability to use applications, and the cloud provider manages the applications on the back end, the updates, the hardware that it runs on, where the data is actually stored, but it is up to you to maintain the data. That's software as a service. Now, I mentioned another one, platform as a service. Platform as a service is really good for development, because if you're not aware, prior to having like a platform as a service, if you wanted to develop code for specific software, what would you have to do? You would have to stand up a server, you'd have to put the operating system on it, install it, configure it, get the programming language you need to run on it, and then you're ready to start coding. Platform as a service is a great cloud service that's provided, because what it does is it gives you the ability to almost a la carte pull down that environment and get started programming right away. Platform as a service offers you the runtime for your development of your code, your applications, without having to worry about all of the infrastructure surrounding it. And it allows you to create applications and deploy them to market a lot quicker than having to personally on site stand up all the infrastructure to even get started developing your applications. One of the last ones, and this one is really interesting, this one's what is called infrastructure as a service. Infrastructure as a service is the ability to create things like virtual machines, create things like network routers, create things like firewalls, if you will, desktops. We can create entire desktops that allow us to do a cloud-based virtual desktop infrastructure, where I can create a virtual desktop that's running on a virtual machine in the cloud, and I can have Ronnie connect to it through the web browser, and to him, it looks just like a normal Windows desktop, but it's stored in the cloud. So that saves us the benefit of doing things like deploying physical machines on premises, or having to deploy a physical virtual desktop infrastructure, which still takes things like cabling, takes servers, takes things like thin clients. We still have a lot of setup that we have to do on-prem. We can offload this infrastructure, we can create it all in the cloud, using the cloud provider's infrastructure. That's your infrastructure as a service. So as a recap, the three models: software as a service, infrastructure as a service, and platform as a service. These are the three service models that I would be aware of, whether you're on a certification exam or if you're just supporting somebody at a help desk level where you need to support cloud-based infrastructure.
Now, along with that, we want to talk about the differences, or actually, I guess, the different characteristics that there are to define the cloud?
Sure, and there are quite a few different ones. There's a few of them that kind of are synonymous across the field, and that's one of the ones. Ronnie kind of already hinted to this in the beginning of the episode, and that's the sharing and pooling of resources. Right? Generically, they say the sharing of resources, but your cloud providers, since you don't physically see the infrastructure, they take large data centers and they pool all of these servers, all of these storage devices together, and they aggregate them together in a way that they can share the resources, if you will, with multiple tenants, right? It's one of the benefits of having your tenant in the cloud. You're using a set of shared resources that Ronnie's tenant could be using, I can be using, you could be using, and we're not really aware of anybody else's tenant. So shared resources is one of those things that they can do. The other thing is something known as metered utilization, right? Metered utilization, remember, one of the benefits of the cloud is a per month subscription basis. But we can also track our utilization, and it's also how the the cloud service providers track what you've used. Think about your electric company when they come and they read your meter. What are they doing? They're billing you for the billing cycle. They're billing you for the amount of power you've used. Same thing happens in the cloud. The resources that you use are what you get charged for, and that measured service allows the cloud service provider and the customer to figure out how much they've used. Let me show you what I mean. For instance, I can do this myself in my tenant by going to something like cost management. When I go into cost management, now keep in mind, ladies and gentlemen, this is specific, if you will, to the Azure interface, right? It's not going to be the same thing all the way across the board. All right, and if I look, and yep, where did it go? I probably zoomed in a little bit and missed the blade. There we go. So notice it tells me the amount due. I'd like to see that, Ronnie. See zeros all the way across the board. It shows me what the billing invoice is. I could see right here that looks like I do have a little bit of something going on. I have 57 cents I owe. Looks like I haven't been paying attention to my metered service here, right? And I can see what the charges are per month. I can download all of the usage and the prices. So we get a very good understanding of what we are utilizing. Two other very important concepts is that rapid elasticity. What does that mean? I want you to think of a rubber band, right? We could stretch a rubber band out, and then if we loosen up, it goes back to its original size, right? So elasticity. This means that this is the ability that if I create a virtual machine and it doesn't have the power that I need to perform whatever it's supposed to perform, I can dynamically add more resources to this to accommodate for that lack of performance. But then when I don't need those resources, they are terminated, or they are canceled, they are stopped, and it reduces back down to the original size. That's the benefit, another benefit of the cloud. The ability that I can prepare for things like Black Friday, Cyber Monday, when we usually don't have that much business. When we do need that business, we can spin up those resources fast. Once that date's gone, they can then reduce back to their original size, if you will. High availability is also an important thing, and that is the ability to have access to the resources when you need access to them, when you should have access to them. That is typically dictated by what is known as a service level agreement, the amount of availability that you will get. The other thing that it allows us to do, finally, ladies and gentlemen, amongst many other things, is things like file synchronization. The ability to have access to your information regardless of the location that you're at, and being able to synchronize it across mobile device or multiple different device types. Ladies and gentlemen, these are some of the models, the services, and the characteristics that I would be aware of for certification endeavors and your help desk roles.
Thank you for watching IT Pro TV.
You may hear the buzz term virtualization, but what are the benefits and requirements of it? Well, find out more next.
You're watching IT Pro TV.
Virtualization is not just a buzzword. It is an important technology that you're going to encounter as an IT professional, and that means we need to dive a little bit more into it. And to help us out, Mr. Wes Bryan. All right, Wes, this is one of these technologies that we hear all the time in the IT world, but if you're new, it's a little bit more challenging. So how are we going to tackle this?
Sure. Ronnie, what I thought we would do here in this episode is rather than just get right into what the purpose is and what the requirements are, which we're going to tackle, we would start by talking about, just stepping back a bit, talking about what virtualization is, and then we'll get into some more of the stuff that we, if we're tackling a certification exam, that we need to know.
All right, sounds like a lot for us to cover. Why don't we head on over to the bench?
All right, everyone, come on over here and join me, and let's dive into this conversation, this mystical technology called virtualization. And when we talk about virtualization, well, what is virtualization? Well, virtualization is a fascinating technology that allows us to do some things that we really couldn't do many years ago. And what that is to take this physical hardware, the operating system that's running on it, and turn it into a software device, turn everything into software, right? You might hear it, turn it into a logical representation. When we say a logical representation, what we're meaning is software-based, right? And we can create an entire software-based computing system. Hardware, the RAM, the CPU, if you will, the network adapter, the operating system that we typically install into a physical machine is now being basically just turned into software. And here's where the inception part comes in. We can run a computer system within a computer system and then run additional computer systems in one single physical hardware. That's one of the benefits of virtualization. One of the things we can do with virtualization is that a operating system no longer has to be dependent on a specific piece of hardware. We can kind of get away from that, and we can lay a layer over the hardware, and we can then start to install multiple operating systems on them.
Yeah, there's an analogy I like to use to try and help somebody that may be trying to understand the idea of virtualization. Think about it as a person driving a car to work. And you might go, what does that have to do with anything? Well, I drive to work every day, and I'm in my own vehicle, so I have to actually pay for everything that's there, the entire car, as well, of course, as fuel. But that is pretty much my personal space. And even though there are actually 3 additional seats in the car, nothing's actually being used on those other 3 seats. I am the only one driving it. Virtualization really does help us in this sense, is that it's more like carpooling. In the idea of carpooling, we're still going to the same place to work, we're still doing the same things, but now I'm actually adding, well, maybe 2, 3, maybe 4 possible additional people using that same machine, which is, of course, my car. So it's kind of a neat technology because it allows us to do that, whereas one time we wouldn't have actually had that ability to do so, right, Wes?
That's right. I remember when the HAL became, a hardware extraction layer became such a big thing because programmers no longer needed to know every single thing about the hardware that they were writing software for, right? We could have this little layer in between, and we could say, hey, just write to that layer, and that layer is going to take care of it for you. Well, that's the great thing about virtualization, is I can run operating systems on hardware that it was never meant to run on. And that's really, really good. It's a really good thing. Now, I tell you what, Ronnie, let's talk about those machines. We've kind of just mentioned those machines. Let's start with the very first machine. All right, the first machine you're going to hear is what is called a host machine. So what is a host machine? Well, a host machine, that's actually the physical device that all other machines are going to run on. We'll talk about what those other machines are here in a second. But that physical machine, if you will, it is the machine that runs the virtualization platform. Right? It is the one that houses all of the physical components that we're going to need to run additional or have additional passengers in the car. That consider those the additional machines that we're going to run on this one physical machine. Mm-hmm. So that's the host machine. Now, there's another machine that we also talk about too. You might hear us call that, say, the guest machine. All right? Well, that's typically what a virtual machine is. Now, what is a virtual machine? All right, the virtual machine is nothing more than really a file, a folder that contains an image, a software representation of all the hardware that it needs to run on, and including typically an operating system that's been installed on it. Now, the reason I call it a guest machine is you hear hosts and guests, right? Ronnie, he had the host machine. His car was the host machine. It had all the hardware. He's driving it. He's got his hands on the steering wheel most of the time. He's pushing the gas, pushing the brakes, right? Got to gas it up, right? He's hosting the guests that are in the carpool, right? Our guest machines essentially are those other people that are now in the car utilizing, here we go, through the virtualization software, that one car's resources. So if you hear guest machine, I'm going to say virtual machine, but you might hear me say, hey, let's take a look at the guests, right? But note that that's a synonymous term, right? The host, the guest runs on the host. The guest is what we call the virtual machines. And one of the beauties about this, Ronnie, is the fact that it acts and behaves just like a normal computer. Why is that? All right, well, the reason that is through a component known as a hypervisor. A hypervisor is a piece of software within the virtualization platform that allows those guests, the guests in the car that are carpooling, to communicate with the physical host's resources that we're running all of this on. That's the hypervisor. Now, I do want you to understand that there are two types of hypervisors. There's a type 1 and a type 2 hypervisor. All right, the type 1 hypervisor is one that we see in our production environments. In fact, if you were to visit the cloud right now and maybe you were to say, hey, I want to take one of these images and I want to spin up a Windows server or a Windows virtual machine. Well, what are you doing there, right? Well, what you're actually doing there is you are running virtualization. That is a guest machine that's running on their virtualization platform. Now it's cloud, but you don't actually see that behind the scenes. At the end of the day, this gives us the ability to take a single physical machine and simultaneously divide up its resources and run multiple instances of these virtual machines all at a single time.
Now, with that idea that you're actually talking about, there has to be some type of requirement, right? Because not every machine can do it.
That's right, Ronnie. So let me show you here. I know I've been talking a lot here. I'm going to get into our Windows machine here. And by the way, ladies and gentlemen, what you're seeing here is not a virtual machine. This is my physical machine that I run. The hypervisor or the virtualization platform is in the background. We'll get back to that here in just a second. Let's dive into a little bit more about what Ronnie asks. I'm going to use a command that you should be aware of if you're in certification exam mode right now, and really if you're in support desk role. I'm going to do msinfo 32, and that's going to bring up my system information app. And one of the things that we're looking for specifically is, and by the way, I kind of did that really fast. So in the system information, if I do system summary here, I can get just general information about my Lenovo ThinkPad here. But if I scroll all the way down to the bottom of this, there's going to be something that I'm looking for. All right. Do I have a hypervisor? Has that hypervisor been detected? All right. Well, the hypervisor is actually inside, the functionality is brought to you by the CPU itself, all right? And I can find out if my CPU supports virtualization in a Windows world just like this, just by typing in msinfo 32. I can also do this by booting into the BIOS, and I can find out if I'm running an Intel processor, I should be looking for a technology called Intel VT. If I'm running an AMD processor, okay, don't matter if it's Intel or if it's AMD, but if I'm running AMD, I'm going to be looking at something known as AMD V. All right. The other thing I'm also looking for is whether it's turned on or off in the BIOS. Sometimes you can see it's turned on by default. Other times it might not be turned on by default. If you're supporting a computer that didn't come from the factory, it could have been disabled for one reason or another. So you also have to understand that your CPU needs to support it, but not only support it, it needs to be turned on. And one quick way you can find out if your software here in Windows will support this virtualization technology without booting into the BIOS, you can just run msinfo 32 and just come over here to your system summary and then pay attention down here all the way to the bottom that it says a hypervisor has been detected, and it says features required for Hyper-V will not be displayed. But don't worry about that in the background because I already have Hyper-V installed and it is running. All right, so that is one of the resource requirements, Ronnie. Hopefully that answered the question there for you, but it requires that CPU, those technologies, and enabled in the BIOS. That's one of the first things that we need. Another thing that we need to keep in mind is that the host machine, right? Ronnie's car, all right? Well, your guest can't carpool with you if you don't have gas in the car. You can put them in the car all you want, but you're not going anywhere, right? So the car needs some gas, right? Amongst many other things that it also needs. Well, your host needs something to operate on. First of all, it needs something to operate on itself, because this is just nothing more than a normal operating system running on a laptop in my case. However, you have guest machines, and the guest machines require resources. In case of Ronnie's car, they need a seat. They need a seat belt, right? I don't know, maybe they need a cup holder. Maybe they need a little AC, right? Those are the resources that they might need in a carpool. But here in your virtualization realm, what you need is enough RAM to support the host, all right, but then also RAM that you can allocate to those guest machines that you create. You also have to have a CPU that's typically has multiple cores in it. If it's hyper-threaded, that's okay too. But a lot of times they have logical processors in there, and those processors can actually, just that little logical processor can be handed over to a guest operating system, or a guest machine, if you will, as a single, what we call vCPU, a virtual central processing unit. We also need to make sure that we have enough storage. We have to make sure that there's enough RAM. And then finally, we have to make sure that we have a network adapter. All right. And one of the ways you can tell that too is really, I love having MS Info up here, because it can tell me how much RAM I actually have, what kind of hardware resources. I'm going to go back to the system summary for now, because it's just a little easier. And I can see that the installed physical memory that I have is 40 gigs. All right. I know what I have right now that's currently available is about 28 gigs. So I can see that I have additional resources to essentially allocate out to the various virtual machines that I need to create. Remember that your guest machines are going to use the host machine resources. And if I allocate a certain amount of RAM to one machine, that's not going to be available to the other machine, and it's going to remove it from the host machine as well. So you have to make sure that you don't over-allocate. Allocate what you can, but don't over-allocate, because then you're going to have issues.
Yeah, the other requirement there would also be hard drive space, right?
That's right. You got to make sure that you have enough hard drive space. And let me show you here. Let's go through the process of creating a virtual machine, and you can see kind of what it looks like. So I'm in the Hyper-V manager here, and when we look at the Hyper-V manager, it is what is known as a Type 1 hypervisor. This is one of the ones that we talked about that is a production based hypervisor. I didn't mention the Type 2, and I do need to kind of go back to that, because the Type 2 hypervisor is a little bit different. A Type 2 hypervisor works just like any other software. If you have an Adobe PDF reader up, if you have Minesweeper up, right? Those are applications that are running on your operating system. While a Type 2 hypervisor is just a virtualization platform that runs side by side with those other applications. A Type 1 hypervisor that runs like this, it's the only thing that's running on that machine, and the virtual machines sit above that abstractly within a layer. And that's why the Type 1 hypervisors we see in production, because they offer a greater level of efficiency. They have a lot of technologies in order to optimize the performance. A Type 2 hypervisor is perfect for testing. Because of the extra layer that's in there, it isn't good for scalability, and it certainly isn't good for optimized performance. Now that we took care of that, and I told you what the Type 2 hypervisor is, let's go ahead and double back on making a virtual machine. So I'm going to go ahead and see if I can zoom in a little bit so you can see that. I'm going to right-click on my computer here, and I'm going to choose New, and I'm going to choose Virtual Machine. All right, and this is my new virtual machine wizard. All right, and it's going to give me a couple things that I should look at, and consider before we start creating a virtual machine. But then I'm going to go ahead and I'm going to choose Next, and we'll call this, let's call this the A+ demo. All right, and we'll do Next, And it's going to ask me what kind of virtual machine do I want to create, Gen 1, Gen 2. So for the purposes of examination, remember that Gen 2 or the Gen 1s, these are an older generation. They don't have all of the additional newer features, so they do have limitations. The Generation 2, it supports 64-bit guest operating systems and a slew of other good, more modern technologies like your UEFI BIOS, Secure Boot, so we get a lot of other features with that. And we're going to choose next. Now, I can also assign, here's where the memory comes in. All right, I have to figure out how much memory do I want to assign to this machine. All right, now, I can assign it 2 gigs, right? Or that's not 2 gigs. Let's try 2 gigs and actually 2 gigs. All right, now I've assigned it 2 gigs. But when this machine starts up, I have to understand that it's going to take 2 gigs out of the pool that the host machine provides. So you can only allocate the resources that you have. That is something to keep in mind as part of creating a virtual machine. All right, let me go ahead and get out of this. And we'll choose next. And now I can connect it to a network as well if I want. Again, it's a virtual network. It's all done inside, through software inside of the virtualization platform. I'm going to leave this not connected for now because it doesn't matter for our purposes here. Now, Ronnie also made good mention about the hard drive, right? We need to have a certain amount of disk space available to allocate to this machine. Now, it's by default going to try to do 127 gigabytes. I'm just going to do 60 because we're not going to use the machine anyways. I just want you to see how we would get this up and running. And then we choose next. And then I'll install an operating system later. I'm going to choose next and then finish. And what we'll see here is that Hyper-V has now created me a virtual machine. And if I right-click on that and I choose settings, we can see that this virtual machine now has a certain amount of memory. It has a virtual processor assigned to it, a drive that has been created for it, and, well, we don't have a network adapter connected to anything right now. So there is your virtual machine, and those are a little bit about some of the resource requirements we need to be that need to be available in order to go into any kind of virtualization endeavor here.
Now, when it comes down to the idea of security, because it's running within a host machine, what about the security of the virtual machine?
That's a good question, Ronnie. And please understand that even though we're saying it's software and it's I'm going to use Steve Jobs' word, it's magical, right? It really isn't. It's a computer, right? It operates the same way any physical computer does. So when we talk about the security requirements of the virtual machine, it needs to be the same security requirements you're implementing on the host machine. All right, which you should be, if you're implementing antivirus, firewall, and you have these locked down and configured the way you want, password protection. You want to do the same thing for your virtual machines. You don't want to leave them unprotected because somebody can gain access to them and they aren't protected, then they can gain access to the information that's on them. And you might say, well, wait a second, Wes, it's just a virtual machine. Well, we're going to talk about some of the benefits, but keep in mind that virtual machines can contain sensitive information that you potentially don't want people to have access to. And I'll come back to that here in a bit.
All right. Now, the other thing that we had mentioned at the beginning of the show was the idea of what the purpose of actually running these things are. So what are kind of the generic purposes for this?
Yeah, sure, Ronnie. So, one of the things I love about virtualization and one of the biggest benefits I like is if we look at the Hyper-V Manager here, I have 5 virtual machines running within this single physical host machine. The great thing about this is I still have memory left over that I can allocate to additional machines. And that's one of the major benefits of virtualization is the fact that we can allocate a physical machine's resources more efficiently today than we could in the past. In the past, let's say I needed a server running a Windows Server operating system and I needed DHCP installed on it. We'd go through that whole process, and then when you look at Task Manager, in fact, let's show you. You look at Task Manager, let's find out how much is my machine currently performing. Well, I've got a couple virtual machines running and I'm still at 4% of my CPU utilization. You've seen I've got 5 machines here and I only got 10 gigs of RAM being used. I still have another 20 that I could allocate. I haven't even used 27%, all right? And that's one of the benefits, right? we have sometimes underutilized resources that now can be allocated to additional machines and more efficiently utilized. In a production environment, you now reduce the energy footprint, right? We don't have to have all of these racks and racks and racks and racks of servers. We can actually consolidate that if virtualization is the way we choose, and we can put all of those servers onto a single physical machine. That's one of the main benefits, better allocation of the resources. Now, what we're talking about here isn't so much a production-based virtualization platform, because there's many other benefits that we haven't even touched the surface on, but this is client-side virtualization. Notice my client Windows 10 machine here. So what are the benefits of the client? One of the benefits of the client-side virtualization more than anything else is that sandbox, right? You might have heard of that term, sandboxing. Well, what does the sandbox bring to you? But it brings an isolated environment that is protected, the host is protected from, is what I'm trying to say. Imagine if Ronnie came to me right now and said, hey, Wes, I need you to test this software out. Not exactly sure what it's going to do, but I need you to test it out. I put it on my production machine. It does something to my production machine, and now I am stuck. I have to wait. I have to re-image my machine, which really for me isn't that big of a deal, but I have to go through that process to get my operating system back the way it was before I broke it, right? True story. No, just kidding. So the sandbox allows me the ability that any one of these virtual machines here that I'm running, if I do something wrong on them, I configure something wrong, well, that's okay. I can undo those changes and revert a virtual machine back to its state before I ever did anything to it, just by a simple click of a button. That's one of the great things about the sandbox, right? We can do test development. And remember, one of the things I told you needed to password protect your machines? You said, well, it's a sandbox, right? Well, if you're doing test development, you might have proprietary intellectual property that you're testing within that machine that you don't want other people to have eyes on. And that's why I wanted to come back to the fact that the security requirements are very, very important for your virtual machines as well, too. Another thing that we can do, and this is a big one, application virtualization. That is probably one of the best things that we can do. And let me show you what I mean by that. I have on my machine, I have Notepad++, all right? And the version of Notepad++ that I'm running right here, if I do an about, we jump in, I can see is 8.1.9.3 there. I'm going to go with the higher version, 8.1, right? Now, let's say that software that Ronnie wanted me to test was Notepad++, and by the way, it wouldn't crash my system, but he wanted to test 8.2. But we don't want to get rid of 8.1. Well, how do I do side-by-side testing like that? That's going to be a little bit difficult, because if you've ever installed a newer version of a piece of software, what happens to the old version? It gets uninstalled and deleted, right? Imagine being able to do side-by-side testing so you could test a newer version. You could do it cross-platform, right? I could run a version of this software that was made for Windows on Ronnie's Mac. Something that was never made to be run on that platform through virtualization now becomes cross-platform, right? If we have legacy applications that maybe there aren't going to be any shims, there aren't going to be any workarounds, and they're not developing code. Well, we can virtualize the whole operating system environment and put the application in it and use it just for that application. Right, so it's great to test. Let me show you the side-by-side that I was talking about. So we don't get, which machine am I on? This is my host machine running this. Let's go over to my file server here. My file server is running in the background here. And let me go ahead and connect to it. Give it just a second. Hopefully it'll connect. There we go. And you guys, and we'll get to see how well I type a password. Hopefully that's got it. And when we get logged in here, I've also got Notepad++ running on my server as well. And what we'll get to see here is that we have a side-by-side version, in fact, of Notepad++. I went ahead and already pulled it up, all right? But I want you to see that it's 8.2. And now I can run these side by side and I can test them. Why? Because one is running in the virtualized environment and one is running on my host machine. And that is that isolated sandbox as well that we're talking about, where you're not mixing and mingling with the host. I can do all the testing I want of the new version of the application, and at the end of the day, I just shut the machine down and I'm good, right? So we get all of those wonderful benefits of being able to perform sandboxing, being able to perform testing, if you will, application virtualization, being able to run applications on platforms that they were never designed to run on. When an application becomes legacy, meaning there's no more vendor support and we're not moving to the newer operating systems, we can put it in a virtual machine and we can run it on our host and we can isolate it from the host, so we're not worried about it damaging the host. A lot of benefits, and we're really only scratching the surface when it comes to virtualization. Virtualization is a fascinating software, and I would encourage any of you out there to try virtualization out for yourself. Go out to a place like VirtualBox that's open source, it's free, it doesn't cost you anything. You can download it, you can run it on your machine, provided you use some of the tricks we've shown you here to determine whether your computer will run virtualization. And at the end of the day, if you're an exam endeavor, you're going to be doing good. If you're in a support desk role, you're going to be doing awesome as well.
Thank you for watching IT Pro TV.